Again, welcome to CS332 class, operating system. Again, given at Rutgers University, New Jersey. In these lectures, we're going to continue with the operating system introduction, and we are going to cover the concept of computer system architecture and also the overview of many types of computing environments, such as distributed system, cluster system, peer review, networking, etc. We're also going to explore the operating system features. So we start with the computer system architecture. Again, we know many years ago, most computer systems use a single processor containing one CPU with a single processing core. Again, the core is the component that executes the instructions and also the registers for storing data locally. So again, most systems have a special purpose processors as well. And in the modern computer system, we have a multi-process system. So this system growing in use and is very important. So also known as a para system or tightly coupled system. So again, our modern computers, even from the mobile devices to servers, multiprocessor system now dominates the landscape of computing. Traditionally, such systems have two or more processors, each with a single core CPU. So the processors share the computer bus and sometimes the clock. They also share the memory peripheral devices together. So this is one of the advantages of a multiprocessing. Since we have more than one processor, then the computer can do more than one job at the same time. But again, the overhead is the communications among the processors, since they are going to share most of the computer resources. So the advantage again will be it increased throughput. As we said, one person building a house and two people building the same house. Surely the two people may finish faster or quicker than one person if it's the same size of a building. But it will not be twice of the time, because there will be a communication between the two people, which will be again an overhead. Also, the economic of scale will be another advantage. Also, the increased reliability. So there will be a graceful degradation of fault, again, tolerance. And that will be the benefit of this model, again, multi-processors. Since, again, many processes can run simultaneously, as we said earlier, they can do two or more. Let's say if it's n processes, then we may do n jobs at the same time. So we have two types of multiprocessors there: asymmetric multiprocessing and also symmetric multiprocessing. So with the asymmetric multiprocessing, each processor is assigned a special task. But with the symmetric multiprocessing, each processor performs all tasks. And again, the most common multiprocessor system use the symmetric multiprocessing. Here, each PS CPU processor performs all the tasks, as we said, including the operating system functions and also the user processes. So we have an example of a symmetric multiprocessing. We can see that again, each one have its own registers, cache, and CPU to perform its task. So we have 0 CPU, 0, 1, and 2, 3 CPUs. But at the same time, they all share the main memory together. Share the main memory together. So the definition of multiprocessor has evolved over time and now includes multi-core system, in which the multiple computer cores reside on a single chip. So multi-core system can be more efficient than multiple chips with single core, because on-chip communication will be faster than between chip communications. So the one we have here now is between chip communications. So the modern one again have again what we call the multi-core system. So the dual core design, here we have the multi-chip and multi-core. So here we can see the difference between the two diagrams. Here we have each chip have its own CPU, register, and cache. So the communication between the chips may take a little bit longer. But with the multi-core, we have two CPU in one, again, surrounding. So here, communication on it will be more faster. So next we move to the concept of cluster system, which is again different from multiprocessing. So this is another type of multiprocessing system, but it's called a cluster system, comparing to the symmetrical and asymmetrical multiprocess, which gather together. So cluster system normally will gather together multiple CPUs. And as we said, the cluster system differ from multiprocessor system, which was described in the previous slide. They are normally composed of two or more individual systems. So we have two or more, so like multiprocessor system, but multiple systems working together. So usually they will share storage through the storage area network. And also they provide high availability service which survive failures. Since again, cluster system is, each system is working individual, but again, they are sharing, in this case, storage area network. So there will still be a communication. Likewise too, again, multiprocessing, cluster system also have asymmetric and symmetric. So with the asymmetric clustering, it has one machine in a hot standby mode. So one machine is working, but always have a standby mode. But with the symmetric clustering, it has a multiple nodes running application, then monitoring each other. Again, the most common one is the symmetric clustering. And some clusters are normally used for high performance computing. So the application must be written to use parallelization. So it's more or less like we have two systems working separately, but at the same time communicating with each other. With cluster system, we may have two computers in two different locations. But again, they are working together to perform a task. Also, we have the distributed lock manager. And the distributed lock manager normally is to avoid conflicting operations among the clusters in the computer. So this example of a cluster system, we can say we have the computer by itself. So we can have, here we have three computers. These three computers can be in three different locations with connections, networking connection among them to communicate. But they may share the same storage and they may work together. So what are the operating system features? We start with the multiprogramming, which is the batch system, which again needed for efficiency. And here with the multiprogramming batch system, we say the single user cannot keep CPU and IO devices busy at all times. So a programming organized jobs, both the code and data. So CPU always has one to execute. And also the subset of a total jobs in a system is kept in memory. So one job selected and run through job scheduling. Again, we may get detailed by the concept of process synchronization, job scheduling, etc. in the future lectures. So when it has to wait for IO, for example, OS will switch it to another job. Normally we can use the system calls, and that's the concept of interrupt also. So time sharing also is another features for multitasking. And this is a logic extension in which the CPU can switch jobs so frequently that users can interact with each job while it is running, creating interactive computing. And that will give us a very good response time, which will be normally less than 1 second. Now, when the response time is very long, then the user may feel the interruption that the job is switching from one location to from one process to another. So each user has at least one program executing in memory process. And if several jobs are ready to run at the same time, there will be a CPU schedule. Now, also if processes don't fit in a memory, then we may use a swapping move. And the swapping moves them in and out to run. And we may discuss the concept of swapping when we cover the memory management. Also, virtual memory allows execution of process not completely in the memory. So there are some technology whereby we can use our hard drive, part of our hard drive, as a memory, which will be acting, we call the virtual memory. So this is a memory layout for multi-program system. And we have the operating system, and we have up to 4 different jobs. And here we can see the memory is 512 megabytes, 0 to 512. So operating system operation, so we have the interrupt driven. And the interrupt driven can be both hardware and software. Without interrupt driven, which means if one operating system is doing a work, we need to wait until the work is done before another work will be started. There will be no interruption. So interruption features make it possible for the operating system to switch jobs, which is again scheduling the CPU. So the hardware interrupt by one of the devices. Also, we have the software interrupt, which can be exception or trap. And so software error, example will be division by 0, there will be an interruption. Requesting for operating system services. Other process problems include infinity loops, processing, modifying each other or the operating system. We also have the dual mode, and the dual mode operation normally allow the operating system to protect itself and other system components. So that's for security. So for example, we have the user mode and the kernel mode. Normally in the kernel mode, we may have access to all the computer resources. So if a program is running, where a process is running in a kernel mode, it has access to all the computer resources. So it's not safe. If the program crash, then the whole computer may crash or some of the device may crash. User mode is more secure mode, but when we are executing a program or a process in a user mode, the program don't have access to computer resources. So this is a concept of what we call the context switch. I execute a program in the user mode. If the program needs the resources, you have to change the mode to kernel mode, because they always change to kernel mode and get the services from kernel mode to be executed. So the mode bit, again, provided by hardware, which provides ability to distinguish when system is running user code or kernel code. Very important. This always happens because applications normally will be executed from the user mode. But when the resources is needed or access to resources, then it has to be switched to kernel mode. So some instruction designated as privilege only. So if an instruction is designated as a privilege, the reason because it can have access to all the computer resources. So which means only execute in the kernel mode in order to have resources. So system call changes the mode to kernel mode and return from call reset it to the user. So we discussed about system call, which give the concept of context switch. Anytime operating system wants to do some work or we're requesting a work to be done by operating system, we have to send a system call request. So system call is more or less a program that will tell operating system to do some work, to request some work. So increasingly, CPUs support multi-mode operations. Multi-mode operations sample with the virtual machine manager mode for guest virtual machines. So transition from user to kernel mode. Here we can see our diagram. The blue section is the kernel mode. The gray is the user mode. So user will process some work. So you'll say user process executing. But when the user process is executing and it needs the data, then they call the system call to request the service from the kernel mode session, since kernel mode have access to all the computer resources. So here we say the system calls in a trap. The trap mode, mode bit equal to 0. Then we execute the system call. The result we get, we return it back to the user application at the user mode section. So timer to prevent infinity loop. We use a timer to prevent infinity loop. That is the process hogging resources. And also timer is set to interrupt the computer after some time period. Keep a counter that is decremented by the physical clock. Also, operating system set a counter. This is a privilege instruction. So when the counter is 0, generates and interrupts a setup before the scheduled process to regain control or terminate program that executes allotted time. Process, we have operating system also have a process managing features. So a process is a program in execution, and it is a unit of work within the system. Program is a passive entity. So a program is the same as a process, but a program is when it's the code is storage, it's in a storage place. It's not running, so we say it's a passive entity. Then a process will be a running or program that is being executed. So you will say process is an active entity because it's a program that is being executed. So a process also needs resources to accomplish its tasks. Since it's running, so example would be the CPU in order to be executed, and also memory to store its data, and also I/O to perform its I/O operations, files to get the data, and also should be able to initialize the data. Also, process termination requires reclaim of any reusable resources. When we terminate a process, then the remaining resources that has not been used will be reclaimed by the OS. Also, the single thread process has one program counter, which is specified location of the next instruction to execute. As we said earlier in chapter 1, the computer CPU always have a special features called the program counter. Program counter always point to the next code to be executed, which make the CPU not to be in an idle stage. So a process also executes instructions sequentially, one at a time until completion. Also, a multi-threaded process has one program counter per thread. As one program counter per thread. And a typical system has many processes. Some operating system running concurrently on one or more CPUs. So concurrency by multipressing the CPU among the process. And we may discuss the concept of concurrency in our next lectures, and when we discuss process synchronization. So these are some of the activities a process manager will perform. So we say process management activities. The operating system is again responsible for the following activities, which are in connection with the process management. For example, creating and deleting both user and system process. Also suspending and resuming process. Also providing mechanism for process synchronizations. Also providing mechanism for process communication. And also providing mechanism for deadlock handling. And the next one will be our memory management activities. Features by the OS. Now, to execute a program, always the instructions and data must be in the memory. So memory is a very important tool of features from operating system. So we say all or part of the data that is needed by the program must be in memory. And also memory management determines what is in memory and when. And then optimizing the CPU utilization and computer responses to users. So management of memory activities may be keeping track of which parts of memory are currently being used and by whom. Also, we need to decide which processes or part and data to move into and out of memory. Again, deciding which process or parts thereof, and also the data to move into and out of memory. Also allocating and deallocating memory space as needed. And we have the storage management. The operating system also provides uniform logical view of information storage, the abstract physical properties to logical storage unit, which is the file. And also each medium is controlled by a device. So if it's a hard drive, I may have a disk drive or a tape drive, etc. The varying properties include the access speed. For example, we know the tape drive access speed will be very slow comparing to hard drives. So the speed again is the capacity and also data transfer rate. Then next is the file management. So files usually organized into directories, access control on most systems to determine who can access what. Operating system activities also include creating and deleting files. That's for the file system management. Creating and deleting files is a primitive to manipulate files and directories, and also mapping files onto the secondary storage, and then the backup files onto stable, non-volatile storage media. So usually, again, this is used to store data that does not fit in the main memory or data that must be kept for a long period of time. It's called the mass storage management. So we may have a proper management. Is of central importance for this concept, mass storage management. Also, the entire system of the computer operation that hinges on this subsystem and its algorithms. So OS activities will include the free space management, the storage allocation, and also the disk scheduling. Some storage need not be fast. We also say some storage needs not to be fast. We have the tertiary storage include optical storage, magnetic tape. State must be managed by OS or application. It will vary between one, which is write once, read many, and read write. So migration of data from disk to register, normally our data will be stored permanent in a storage device, such as example, here is the hard disk, or it can be in flash disk, etc., any permanent storage device. If data needed to be used by the CPU, or the CPU is processing some data, then we may transfer the data from hard disk to the main memory. But that's the only way a program running can, again, access the data. So data will go to the main memory. From the main memory, go to the cache. Cache is a memory that is closer to the CPU comparing to the main memory. Then after cache, we send it to the register. So all these four items, again, are storage devices. The only thing we know, register will be inside the CPU, which is very small storage device, holding the current data or program that need to be executed. Cache will be next. Some technology design of the computer system, we may have the cache inside the CPU. Then the main memory, then again the hard disk. So multitasking environment must be careful to use most recent value, no matter where it is stored in the system. So multiprocessing environment must provide cache coherence in hardware, such as all CPUs have the same recent value in their cache. We also have the IO subsystem. Here we say one purpose of OS is to hide the peculiarities of hardware devices from the user. So IO subset is responsible for memory management of IO, including the buffering, storing data temporarily while it is being used, transferred, cache, which store parts of data in faster storage for performance. Also the spooling, which we may discuss that later on, is the overlapping of output of one job with input of other jobs. Then general device driver interface, also drivers for specific hardware devices. And the last will be the protection and security features in operating system. And protection will be any mechanism for controlling the access of processes or users to resources defined by the operating system. So security be the defense of the system against internal and also external attack. Protection is any mechanism for controlling the access of process or users. So system generally first will distinguish among users to determine who can do what. We may have the user identities, security ID. Also the user ID normally associated with all files or some files processed. So whatever file associated with the ID is the only files that the user can have access to. We also have a group ID and privilege escalation. Privilege escalation normally allow user to change to effective the ID with more rights. Effective ID with more rights. So we have some computing environment. Traditionally, we have a standalone general purpose machines. These machines are not connected to any machine. They work by themselves. For example, I'm home, I have one computer. I'm using it. It's not connected to the internet or any place. So the portals will provide web access to internal systems. Also, we may have a network computers, which we call the thin clients. They are like a web terminals. Example would be you go to the, let's say, the international airport, we may have where to check the desk or the front desk. They may have a monitor and only keyboard. There's no computer around for security. So this monitor and keyboard are connected to the server of the computer. So that's another environment. So mobile computers also have environment. Most mobile computing environments is wireless network. So networking become ubiquitous. Even home systems use firewalls to protect home computers from internet attack. So most of us buy computer again because we need to use the internet at home. So we have the mobile devices such as handheld, smartphones, tablets, etc. All these devices also have operating system, different features. Example would be the Android or iOS. They are for the smartphone for Apple computers. Android can be a smartphone for Samsung and other companies. Extra features, more OS features such as GPS, gyroscope. Also allow new types of apps like augmented reality. Also, we have the distributed environment where we may have collection of separate or possible heterogeneous system network together. So distributed computing may be idea of having two or more computers, even they can be in different locations, but they are connected together and working together. So a computer network, we have a local area network, wide area network. Wide area network example would be the internet. That's a network that covers worldwide. Local area network would be a network in my room or a network in one building. So the different types of network system based on the geographical size. Metropolitan area network may be a city. And then personal area network will be at home, my personal environment. Also, we have the client server, where normally the client, here we have 3 clients requesting service from the server. And these computers are all connected through the network system. Then we have the peer-to-peer review, peer-to-peer. And peer-to-peer here means you have 2 or more computers, they can communicate, they can do everything together, but they don't service each other. They are all in the same level or the same group. Then computing environment for virtualization. This normally allows operating system to run application within other operating systems. This is vast and growing industry virtualization system or machines. So emulation used when source CPU type different from target type. And this will be generally slowest method. So last will be we have our cloud computing, delivers computing storage, even hubs as a service across network. And normally logical extension of virtualization because it uses virtualization as a base for its functionality. Example would be the Amazon EC Square. Amazon EC Square has thousands of servers, millions of virtual machines, petabytes of storage available across the internet, but it's a pay based on usage. Many types of cloud computing. We have public cloud. This is available through the internet to anyone willing to pay. Then we have private cloud. The private cloud normally is run by a specific company. So run by a company for a company's own use. Then we have hybrid cloud. This will include again both public and private clouds components. That's why it's been called hybrid. Also, we have software as a service. This is one or more application available through the internet. We pay for the services. So platform as a service, also software stack ready for application use through the internet. Example will be a database server. Then we have infrastructure as a service, service or storage available over the internet. So that will be the conclusion of our lectures. Again, these lectures focus on different type of operating system, again, features, and also the computer system architecture. Example like peer-to-peer, distributed system, cloud system, etc. So again, wish everybody the best and thank you for your time.